Hi everyone, myself Krish Raidukam, very warm welcome to all. And this in this day we talk about little bit AI Foundation series math topic and the mathematical concept we should to discuss. And overall agenda for today is like the first we discuss about gradient and gradient descent, and that's the really necessary and super important concept of the calculus. And while you're discussing about calculus, a too much important part for an artificial intelligence. And our second agenda is orthogonality. So we look toward their orthogonality, what exactly orthogonality is, and how actually it's work, what the scene, what the behind logics that actually AI use. So I will try to connect this all this both concept with this is, as you know, like mathematical concept is a abstract concept, and I try to connect this all this particular dots with the real world application to understand you much better. Okay, so again, if this particular video is going to be productive for you and if you learn something from there, then it's my pleasure. So let's start it. Let's come to agenda number one. In this agenda, we especially talk about gradient and gradient descent. So what exactly is, and why this particular one is important, and why this particular one is considered an important part of the calculus, especially for artificial intelligence also. So in fact, when we're talking about gradient, so gradient is and gradient descent are both sound similar, but uh, the workflow, the work of the both work in same direction, but differently. Actually, how much they are different, we discuss. Okay, so again, I'm not going to give you like exact big definition of this gradient and gradient descent. Just I keep it simple. I keep the only for 2 or 3 word to explain entire workflow, entire context behind this gradient and gradient descent. So the first one, gradient. The gradient refer to the direction and adjustment. So it's all about direction and adjustment. Now, for example, your model. Okay, a model try to learn. So it's all about adjusting weight. It's all about increasing weight uh, to optimize algorithm. So it is act as a mathematical compass. So here gradient act as a mathematical compass to adjust and optimize algorithm. So it is mathematical compass to adjust and optimize algorithm. So that's the gradient refer to. The gradient is all about optimizing and just as act as a mathematical compass to adjust and optimize algorithm. Okay, so it's give a direction and adjustment. It is a vector quantity, as we know, and this is all about gradient. And second one is gradient descent. Gradient descent is sound similar, minimal cost. Okay, for example, this cost. What exactly cost is? Cost is all about how much your function try to learn. Okay, how much they learn something. Okay, after getting a such as a minimal error. Okay, now suppose predict something, but you get a error, this weight increases, then I think error increases. The cost is all about error, how much the error error created. Okay, when the particular function predicts something. Okay, so the if the particular function the cost rapidly increases. Okay, so you need to just minimize this particular cost, that means minimizing the error at the lowest point. So this particular point and is called their gradient descent. Gradient descent is downhill, to shifting the weight to downhill to adjust the cost. So cost is all about adjustment of error. Adjustment of error. It cost is all about adjustment of error in when their weight increases. Okay, so it's all about when in gradient descent. Gradient descent is all about uphill, downhills. It shifts the weight toward downhill. Okay, it's all about shift the weight toward downhill to minimize the cost. That means minimize the error between actual and predicted output. Okay, so that's the gradient descent. And gradient is all about status function. Status function refer to something, the function that fastly grow. Okay, so it's all about pushing weight to adjusting weight to optimize, and it is act as a mathematical compass to to learning fast. Okay, so that's the gradient. And gradient descent is something like increasing of the weight. If you want to, like, in machine learning model, if model adjust the weight, okay, and increase rapidly, that is the gradient which actually push the weight, and the gradient which actually pull the weight to at minimal cost, that's the gradient descent. So that's the basic difference between both of them, like gradient and gradient descent. So one focus on uphill and another focus on downhill. So that's okay. Okay, so that's all about the gradient and gradient descent. I will try to connect all the particular application of this both of them with the real world application. Just imagine something you are want to try to learn. Okay, it's all about something you want to predict something. Okay, now suppose your model want to predict house price. Uh, okay, but that your model predict some output and there a huge difference between both of them. You need to adjust the gradient descent. Your model try to adjust gradient descent to minimal cost to adjust the cost. So gradient descent work here to adjusting the minimal cost, to adjusting difference between both of the actual and predicted output, both of them. Okay, and that case is really important and matter most over there. And gradient is all about pushing of the weight. You push the weight to like for better output. Okay, and pull the weight, gradient descent. Push the weight, gradient, and pull the weight for gradient descent. So both are sound similar, but the work difference between both of them actually different. But when we're talking about the both of them, like how actually they different are, and what the basic thing that we should to know is all about something. The model always try to push or pull the weight according to the gradient. Okay, so we need to just adjust the weight according to gradient. Like the gradient, first gradient is focused on pushing the weight, and gradient isn't focus on pulling the weight to minimal cost between actual and predicted output. So that's okay. So that's how actually the model try to learn, and they actually specifically understand what the basic difference between both of them. So that's the gradient and gradient descent work. Okay, so that's okay. That's all about the gradient and gradient descent. Let's come to the orthogonality. Hey, let's come to agenda number 2. And in this agenda, we discuss about orthogonality. So what is orthogonality? And basically, that's why this particular one is important. Again, as a promise, I try to connect this particular abstract concept with real world application to understand much better, to connect the all dots that you should to know. Okay, so if we talk about orthogonality, so orthogonality is act as something like when the model want to understand difference between two different features, two different data types, and two different like data sets. The only way possible, the main reason for orthogonality is independent and such as clarity and decomposition. So it actually unlock the three potential, like I think the basically two potential of the model. It's help us to know which particular features are independent, which fit to it improve the clarity between the features, like which one is not dependent from other. Now suppose uh, take the two or three parameter for predicting a house price. Okay, as the house price, like temperature, neighborhood, and square footage. One of the two one of out of this three, I think like two features are not connected with each other, and I think one is out of them, like one is independent, one is doesn't matter will how much your temperature will be, it doesn't affect on your particular room temperature. Okay, so that's all about something like out of this three feature, which features is independent, which are not contributing a role, and according to the some changes in two different features out of this three one. So that exactly how actually orthogonality is work. So in that case, if the it's enable and unlock the opportunity to model to learn how actually perpendicular and how actually independent and clarity. And so that's all about how know there's which particular features are independent from the other one, and it's improved the clarity. Okay, so that's all about it. Actually, the math behind is like two vector. If the two vector are perpendicular from each other, intersect and bisect anything else, it to each other, then you can say this two vector as considered the feature one. This is feature one, okay, and this is feature two. Let's suppose this feature one will be temperature, and feature 2 should be like square footage. So in that case, those features are perpendicular from each other, then it means that this both features are not dependent from each other. If the one of the change, other will no effect on there. So that's okay, that's the temperature and square footage work like this. What exactly mean? If the if these two features are perpendicular from each other, in that's help us to know the particular model, like any architecture like model, uh, which one is independent from each one. So that's help us to contributing important role. The first you should to know about which particular features are independent from each other, then after you move forward. Okay. And dot product and zero, that means dot product is zero if this both are perpendicular from each other. Okay. So what actually orthogonality, the speciality of the orthogonality is all about something, you can say it unlock the generalization refer to learn from unseen data. Your model try to learn something from the unseen data. The only possible way by orthogonality is a like which actually facilitate the model to learn from unknown data, unseen data. They try to adjust and finding the like dot product and cross product to just understand which particular features are independent from each other, and that's basically process the generalization. So it's actually help us in generalization of the model. Okay, to understand unseen data. Yeah, fine, so that's okay. Okay, so I think like orthogonality have the three basic like orthogonal vector, orthogonal matrix, and orthogonal function. So orthogonal vector actually it's all about the features. We can take the features like two features are it's all about it. Orthogonal matrix is all about something data, two data types. Like if we can say orthogonal matrix, how can we say these particular matrix are orthogonal matrix? That if this all this particular matrix are perpendicular from each other on according to their dimensions x, y, z, and particular s, uh, mutually perpendicular, then we can say this orthogonal matrix. And that really helpful in back propagation, while model moving forward layer by layer in backward pass to learn calculate the gradient. Then actually they use this particular orthogonal matrix, and that's unlocked up that without losing information, that actually process the entire gradient. Okay. Okay, second is orthogonal function. If the dot product of the both function are zeros, then you can say this particular function is orthogonal function, and that's a really important one. Okay, uh, that's all about orthogonal and orthogonality, and that's actually important because of that, because it's help us in generalization. The first of all, model always try to learn actually which features are different and independent from each other, and that actually process the information much more. First of all, when you're using PCA concept, you should to know actually when you're making different dimensions. Okay, when you're analyzing the components, then you should to know which particular part is independent from the other one. Then if you just categorize that particular one, then it is easy to process the remaining ones, like which one is dependent. The first we need to process like which one is independent, then after we can analyze much better in PCA. Like PCA, like dimensionality reduction, that's really helpful for orthogonality. So that's all about it. Again, if this particular video is going to productive for you, if you learn something from there, then it's my pleasure.